Hey guys, Mr. Rodriguez, just saying hi. Just wanted to do a little mini lecture on power and hope you're all doing well. Hopefully, you're using this time to learn a little physics and you're enjoying these assignments that I put online for you. Anyways, take care and I'll keep doing this if you guys like it. And if you need more help, just send me an email and ask a question and I'll get back to you as soon as I can. All right, let's get started. Okay, so I'm going to try and set this camera up. Oops. All right, I think that'll work. So I'm going to go ahead and work through the worksheet that I posted on Schoology, which is this one right here. And I'll start by writing those equations. There is going to be at least three, more like four. So we'll start with equation 1. Equation 1 is just going to be power, which is capital P, is equal to the change in energy divided by time. And that's what this is saying is we talked about change in energy in the last unit, but it was work. So we can write our second equation just from that right there. So power is going to equal work divided by time. So power is going to be how quickly we do work, or how slowly, or how quickly we change the energy, or how slowly we change the energy. All right, well, let's go ahead and remember what work is and write our third equation. Power then is equal to FD cosine theta over T. And this, if we look at this one a little more carefully, this quantity right here should ring a bell. You could think of it as speed, but you can also think of it as velocity, and that's what we're gonna use here. So distance, even though we call it distance, is a vector. Force is a vector, and so anyways, we get equation 4 then. I know there's not a spot for it on your sheet, but if you can just write that in, that'll be great. All right, so we can say power then is equal to FV cosine theta. And usually when we use this formula, theta is going to end up being 0, so we're not going to have to worry about it too much. Hopefully you guys can see this pretty clearly and it's not too dark. All right, anyways, maybe that's better. Okay, so let's go ahead and move on now to the examples. The first example says that 50 joules of work are done in 10 seconds. So if we're considering work, we might as well pick equation 2. Always write your equation out and then plug in your variables. Power then is equal to 50 joules divided by 10 seconds, which is pretty straightforward. But this kind of gets at the idea of what the unit for power is. It's joules per second, which is also known as watts. So I'm going to go ahead and write the answer then, which is 5 watts. All right, example 2. Sorry if that camera's shaking a little bit. Gravity causes a rock that is 15 kilograms to fall 2 meters in 9.8 seconds. So I'm working off this one right here. And what is the power necessary to accomplish this? All right, so this one's a little less, or a lot less straightforward. So I'm going to go ahead and draw it. And it's always wise to start with the drawing. So we got a rock that is 15 kilograms. And it's going to fall a distance of 2 meters. Okay, and I think that that's all we know. But we can assume that if it's falling here, oh, we also know the time. Time is 9.8 seconds. but I don't think that that is gonna really tell us how to dig into this problem. I think we got to realize that if it's falling, that there's a force on it, and that force is force gravity. So I'm going to go ahead and draw a dot. Draw FG. Draw 2 meters. And from this, I think we can see now that if we can calculate force gravity, because we can, Fg is equal to mg, that we should be able to solve this problem. Let's go ahead and just keep going there and get mg. So 15 kilograms times 9.81 meters per second squared, or meters per second. And this is going to equal Fg, which is about, 15 times 10. But we can get the calculator just to give it a try and make sure we're closer than the estimate, which you should all be able to estimate that around 150. So it looks like 147.15. And this pen is running out on me a little bit. Okay, so I think that's where we're at right there. So we can go ahead and grab that power formula. And once again, we said we like number 3 there. And just write it right under here, or right over here. Power is equal to FD cosine theta over T. And we can say that power then is equal to force gravity, which is the 147.15 newtons times the 2 meters. What's theta here? If we look at this, we can see there's no angle here between the two, right? So theta is equal to 0. And hopefully you remember that when theta 0, cosine of 0 is 1. So that's what we're going to end up getting, right? But I'm going to go ahead and just write it in anyways, knowing full well that this is going to be positive 1 right here. So it's not going to change anything. Time, this is going to be that 9.81. It just made me realize we could have did this even easier. Understanding that this is 15 times 9.81. Well, let me finish the problem, then I'll explain. So we end up getting 147.15 times 2 divided by 9.81. So I'm thinking it's just going to be 2 times 15, right, which is 30. Yeah, so this ends up being 30. And I'll go ahead and write that in, 30 watts. But I think what I was trying to say is if we come back up here, we can see that if this is, if I go back for a second, this was 15 times 9.81. You can see, right, that this is just going to cancel away. That this is going to cancel that. And we're going to end up with 15 times 2, which is 30, times this, which is positive 1. And so we get positive 30 watts. All right. Hopefully that makes sense. If not, you just plug it all in your calculator and it'll come out with the right answer. All right, last problem, last example. And then you can do the last 3 for practice on your own. All right. Number 3, or example 3. It says a car traveling, oh, it's a terrible drawing. Car traveling at 30 meters per second. Generates a power of 600 watts. I'm just going to jot all this in. And we want to know what is F, right? How much force does this car apply to the road? Okay, and so here we're finding the magnitude, because really we're going to find how much force is applied to the car and then assume that it's an equal and opposite force on the road. But if we just do the magnitude, we won't have to worry about signs or anything like that. So we'll just find the force applied to the car, and the magnitude will be the same as that applied to the road. So if I think about that, and we just solve this, we can say that that V is going to point this way. If I can maybe highlight this in red. And the force on the car is also going to point in the same direction. And we can go ahead and solve for that. All right, so anyways, my point here is that theta is equal to 0. And so we're going to have the same problem as we did before. So we can go ahead and utilize our formula, but this time we don't know time, do we? I don't think we do. And so here we're looking at equation number 4, which is just P equals FV cosine theta. All right, so I'm going to go ahead and solve it the simplest way I can think of. Plug in my my numbers and units. It's tricky because that looks like work. It's the same symbol, and I think that that's mentioned in the video, so don't get confused by that. Watts has the same symbol as work, capital W. And so I'm going to keep this as 0, knowing that that's positive 1. Divide away that 30. I think we can do that in our heads. What's 600 divided by 30? I'll let you think about it for a second. All right, I think we all agree it's equal to 20. And a watt divided by a meter per second. That's kind of tricky there. We should be able to see that since it's got to be force, it's got to be newtons. So we're going to end up with 20 newtons as our force. This is the force on the car. If we wanted the force on the road, which is what the problem technically asked for, you could say it's the same magnitude, 20 newtons, because of Newton's third law, or you could just say it's negative 20 newtons because it's pointed to the left. So usually, or either one is fine here. I could have just went ahead and used cosine 180 there as well, and that would have gave me that negative sign there. But I didn't. All right, so checking those units though, watts divided by meters per second. A watt is power, which is force times velocity. So I guess that makes sense, right? Because if P equals FV, right, like we said right here, then we have newtons times meters per second. So we can just say that this is equal to newtons times meters per second, and this is divided by meters per second. So that would cancel away and just give us newtons. So that works out. Anyways, hope that helped. 3 formulas for you to use, and hopefully with the video, if I went too fast, you could rewind it and go back, or if I went too slow, you could speed me up a little bit. And anyways, all right, take care, and I'll try and make another one of these if it helps. All right, bye-bye.